Good morning, students. Myself, lecturer Rajiv Rattan, SOE, Government Senior Secondary School, Samrala Boys. मैनू जो टॉपिक है सन होया वो टॉपिक है D block elements and their properties. So with the help of PowerPoint presentation, मैं तुम्हारे ये टॉपिक एक्सप्लेन करांगा. Let's start. What are D block elements and general trends of properties? D block elements, definition and general electronic configuration. Elements whose last electron enter in n-1 d orbital are called as D block elements. They are also called as transition elements having partially filled d orbital in ground state or their most common oxidation state. So this is the general electronic configuration of D block elements n-1 d 1 to 10 and s1 to 2. So this is the representation of D block elements in a periodic table. D block elements, they are present between S block and P block elements. They are further divided into the 4 transition series. The first transition series starting from scandium to zinc. In this series 3d orbital is filled. Second transition series starting from ytterbium to cadmium. In this series 4d orbital is filled. Third series starting from lanthanum, hafnium to mercury. In this series 5d orbital is filled. Fourth transition series starting from actinoid to atomic number element 104. In this series 6d orbital is filled. ਹੁਣ ਆਪਣੇ ਕੋਲ ਜਿਹੜੀ ਫਸਟ ਟ੍ਰਾਂਜੀਸ਼ਨ ਸੀਰੀਜ਼ ਦੀ ਇਲੈਕਟ੍ਰੋਨਿਕ ਕਨਫੀਗਰੇਸ਼ਨ ਆਪਾਂ ਡਿਸਕਸ ਕਰਦੇ ਹਾਂ ਸ਼ਾਰਟ ਦੇ ਵਿੱਚ. ਹੁਣ ਫਸਟ ਸੀਰੀਜ਼ ਸਟਾਰਟਿੰਗ ਫਰਮ ਸਕੈਂਡੀਅਮ, ਟਾਈਟੇਨੀਅਮ, ਵੈਨੇਡੀਅਮ, ਕ੍ਰੋਮੀਅਮ, manganese, iron, cobalt, nickel, copper and zinc. So atomic number is increasing one by one. The last electron enter in 3d, that is n-1 d orbital. So देखो 1s2, 2s2, 2p6, 3s2, 3p6, 18 electron हो गए up to argon. Then 4s2, 20 calcium. Then 21st electron that enter in 3d. So similarly 3d2, 3d3, 3d5, 5, 6, 7, 8, 10, 10. Actually electronic configuration जो chromium ਤੇ copper ਦੀ और different expect ਕੀਤੀ ਜਾਂਦੀ ਆ, but actually ਹੁੰਦੀ ਇਹ ਆ. ਰੀਜ਼ਨ ਕੀ ਆ? chromium ਦੇ ਵਿੱਚ ਜਦੋਂ ਆਪਾਂ electronic configuration ਲਿਖਦੇ ਆ ਉੱਥੇ 4s2 3d4 ਹੁੰਦਾ ਆ, but electron 4s ਤੋਂ 3d ਦੇ ਵਿੱਚ ਮਾਈਗ੍ਰੇਟ ਕਰ ਜਾਂਦਾ in order to acquire half-filled stable electronic configuration. Similarly, copper ਦੇ ਕੇਸ ਦੇ ਵਿੱਚ ਵੀ ਕੀ ਆ? ਵੈਸੇ 3d2, 4d, 3d10, but electron S ਦੇ ਵਿੱਚੋਂ ਮਾਈਗ੍ਰੇਟ ਕਰ ਜਾਂਦਾ, it become 3d10 and 4s1. So this is called as the first transition series of the transition element. So ਹੁਣ ਆਪਾਂ ਡਿਸਕਸ ਕਰਾਂਗੇ ਜਨਰਲ ਪ੍ਰੋਪਰਟੀਜ਼. ਫਸਟ ਆਫ ਆਲ ਆ ਗਿਆ ਜੀ ਐਟੋਮਿਕ ਰੇਡੀਅਸ. ਆਪਾਂ ਨੇ ਪ੍ਰੀਵੀਅਸ ਕਲਾਸਿਸ ਦੇ ਵਿੱਚ ਪੜ੍ਹਿਆ ਵੀ ਵੈਨ ਇਨ ਅ ਪੀਰੀਓਡਿਕ ਟੇਬਲ ਵੀ ਮੂਵ ਫਰਮ ਲੈਫਟ ਟੂ ਰਾਈਟ, ਐਟੋਮਿਕ ਸਾਈਜ਼ ਕੀ ਕਰਦਾ ਆ? ਡਿਕਰੀਜ਼ ਕਰਦਾ ਆ. ਸਿਮਿਲਰਲੀ when we move in a first transition series or second transition series or third transition series, atomic number increase one by one and atomic size or ionic radii also decreases. And manganese onward, it remains the same up to nickel, and after nickel there is a rise in the atomic radii of copper and then zinc. So what is the reason? When we move from scandium to titanium, vanadium and chromium, electron enters in n-1 d orbital having number up to d4 they have poor shielding effect. So valence electron, they are strongly attracted toward the nucleus and ionic radii decreases. But when we move from manganese to onward, nickel, electron they are added up to D8. But after when the electron number increases to D9 and D10 in zinc, inter-electronic repulsion increases and size की increase कर जाता है. So that's why there is a rise in the size at the end of the series. Next, trend of the atomic radii down to group. ਹੁਣ periodic table वाली slide ਆਪਾਂ ਜੋ ਪਹਿਲਾਂ ਦੇਖੀ ਆ ਮੈਂ ਤੁਹਾਨੂੰ ਦਿਖਾਉਣਾ ਆ ਉਹਦੇ ਵਿੱਚ ਜਿਹੜੀਆਂ ਸੀਰੀਜ਼ ਹੈਗੀਆਂ ਨੇ ਉਹ ਆਪਾਂ ਨੇ ਸ਼ੋ ਕਰਨੀਆਂ ਨੇ periodic table ਵਾਲੀ slide ਜੋ ਆ ਦੇਖੋ ਤੇ ਧਿਆਨ ਨਾਲ ਜਦੋਂ ਅਸੀਂ ਫਸਟ ਸੀਰੀਜ਼ ਟੂ ਸੈਕੰਡ ਸੀਰੀਜ਼ ਇਹਨਾਂ ਗਰੁੱਪ ਮੂਵ ਕਰਦੇ ਆ ਸਾਈਜ਼ ਇਨਕਰੀਜ਼ ਕਰਦਾ ਹੈ ਜਨਰਲੀ ਆਪਾਂ ਨੇ +1 ਚ ਵੀ ਪੜਿਆ when we move from top to bottom in a group atomic size increases. So according to that, when we move from first series to third series, atomic size will increase. If we see the group 4, when we move from titanium to zirconium, zirconium has more atomic radii than titanium. What hafnium have the same atomic radii like zirconium. So what is the reason behind that? The reason is that when we move from zirconium to hafnium, the 4f orbital is filled before 5d and due to lengthening and contraction जो size हैगा या वो same रहता है due to lengthening and contraction size की रहता same रहता है आ देखो as we moved on to group the first transition series to second atomic radii increases when to third series size remains same means atomic radii of second and third series remains same. The reason behind that is lengthening and contraction. It is very important question पढ़ जाता है पेपर दे विच. So as we move from top to bottom 4f orbital is filled before 5d having poor shielding effect. So interaction between the nuclear charge and valence electron increases and size decreases. Next property, that is ionization energy. Transition elements have more ionization energy than S block and less than P block elements. Next is oxidation state. Transition elements show variable oxidation state. Means different charge. One element show different type of charge. Like here, titanium can lose 3 electron requiring +3 charge. It can also lose 4 electron requiring +4 charge. But similarly, you can see all the transition elements except zinc and scandium, they show variable oxidation state. The reason is that because there is the involvement of both n-1 and ns electron, that's why the transition element shows variable oxidation states. Next property, that is colored compound. अब already पढ़िया भी transition element form colored complexes. Now the key answer that is they show due to dd transition. Splitting of the d orbital into the set of 2, that is called as crystal field splitting. ਇੱਥੇ ਆਪਾਂ ਦਿਖਾ ਰਹੇ ਹਾਂ ਮੈਂ ਤੁਹਾਨੂੰ ਵੀ there are the 9 electrons. It is example of copper +2. So when there is a splitting, the 6 electron in the lower these 3 orbitals and 3 electrons in the upper 2 orbitals. So when there is the light fall, the electron jump from this to this level, then the electron come back to this state. There is the involvement of the colored radiations. That's why the d block elements they form colored complexes. So simple answer ki hai, why the D elements form colored complexes? Due to DD transitions, and that's why in copper, in zinc, cadmium and mercury, they have fully filled d orbital. They have the D10 in their electronic configuration, and they don't have the DD transitions. That's why they are not known as the transition elements. And the salt of zinc, cadmium and mercury, they are the white in color. Next, metallic character. All D block elements are metal having high melting and boiling point, and among these, tungsten, molybdenum and chromium, they have the high melting point. Reason? Because they have the low ionization energy and partially filled valence d orbital and maximum number of unpaired electrons. So in the D block, the tungsten, molybdenum and chromium, these are the hard metals because they have the maximum number of unpaired electrons, that is 6. Tungsten has the highest melting point. It is used as the filament in the electric bulb because it has the high melting point and boiling point. Because in case of tungsten, molybdenum and chromium, there are the 6 electrons in D. They are unpaired, that is D6. So that's why they have the high melting and boiling point. Next property, enthalpy of atomization. All transition elements, atoms are attached to each other by the metallic bond due to unpaired electron, and that's why they need more enthalpy of atomization to convert into atomic form. That's why they have the high enthalpy of atomization. Next property, catalytic property. Transition elements, they are generally used as the catalyst in organic reactions like nickel, palladium, so platinum, these are used as the catalyst. You know catalysts ki andar hai, catalysts, they increase the rate of reaction by decreasing the activation energy. So here we see the diagram. In this diagram, this red line indicates a normal reaction without catalyst. Reactant, they are changing into the product. This is by the red line. But when we add this catalyst, this red bar comes down and the value of activation energy decreases and rate of reaction increases. So it is very, very important. The transition elements, they are used as catalyst because they form a reaction intermediate. This is the reaction intermediate of lower energy and increase the rate of reaction. Next property, interstitial compounds. Transition element form interstitial compound with small elements like hydrogen, boron, carbon and nitrogen. Because these are the small elements and they get trapped in the vacant space present between these transition element atoms. That's why they form interstitial compounds. Next property, alloys formation. Atoms of different transition elements have the same size and they get intermixed with each other and they form alloys. Like bronze, it is copper and tin alloy. Brass, it is copper and zinc alloy. Here we say the gold and the platinum, they have the different color to indicate the different element. What you noticed here, they have the same size of the atoms and they form the alloys. Next, magnetic properties. So magnetic properties, first of all, I explain karanga. What are the paramagnetic substances? The substances having unpaired electron, they are strongly attracted by the magnetic fields. And diamagnetic substance, they have the pair the electron, they are the paired and they are the repelled by the magnetic field. So due to presence of unpaired electron in the transition element, they are generally paramagnetic in nature, and we can find out the magnetic moment with the help of this formula. Here mu is the magnetic moment and n is the number of unpaired electrons. So with this I have explained the properties of D block elements.